It is currently 3:08 a.m. as I record this, so I planned on uploading the full walkthrough for the 2024 NSC Maths Paper 1, but I need to sleep maybe at a slightly reasonable time. 4 a.m. is probably better than 5 a.m. So this video will probably be about 1 hour long, and then tomorrow part 2 will be uploaded. So let's get started. Let me just go to the first question. So in question 1, they ask us to solve for x for a whole bunch of questions. So let's start with question 1.1. So in question 1.1, pretty simple. It is just x minus 3 equals 0. So that tells us x is equal to 0, x minus 3 equals 0, x equals 0. Okay, so that is pretty simple. Then for the next question, 1.1.2, what you're going to do is you're going to say 2x squared, bring the 4x to the left, add 1, and say equal to 0. Because they say they want the answer correct at 2 decimal places, you already know that you're going to be using the quadratic formula. So here, a is 2, b is -4, and c is equal to 1. And I assume that you're familiar with how to do this. So here's the quadratic formula. We divide by, okay. So the quadratic formula is -b plus minus the square root of b squared minus 4ac divided by 2a. And so if we plug in our values here, -4 plus minus the square root of -4 squared, be careful with your brackets, times -4, 2, 1, and we divide all of that by 2 times 2, you will get either x equals 0.171 for the positive on the square root, or you will get x equals 0.29. So nothing too difficult, just take the 4x over to the left hand side and use the quadratic formula, and then you just plug and play and get your answer and round to 2 decimal places. Okay, so question 1.1.3, they ask you x squared minus 2x minus 3 greater than 0. So we'll just quickly factorize this. So I have the 1 times 1 gives me x squared, and then 3 is a prime, so it's only 3 times 1 that can give me 3. So here I have x and 3, x and 1 equal to 0. Now since we want a negative 2x, the larger number has to be negative, the smaller number has to be positive. And so x times x is x squared, -3 times 1 is -3, and -3x plus x gives you -2x. So that tells us the two values that we care about are these two values. Now let's draw the parabola. So if you draw this, you'll get something like this. So -1 and 3. And so they ask us for this parabola, which values are greater than 0? So it would be these values. And so if we want the answer for x, we're simply going to say that x is less than -1 and x is greater than 3. Now note, it's not less than and equal to, because the question says greater than 0. So at -1, for example, the parabola has a value of 0, or the equation has a value of 0, and at 3 it has a value of 0. So that's why I use the greater than, not including. Okay, let's do the 1.1.4. So this one is 5 marks, 5 very easy marks in my opinion. So the main thing you should see here is that 2 to the power 2x. With this over here, -2 to the power x plus 2, you should know this is just -2x times 2, because you know that if I say 2 squared times 2 to the power 3, that is the same as 2 to the power 2 plus 3 equals 2 to the power 5. So it's 2 to the power 2x minus 2 to the power x times 2 to the power 2 minus 32 equals 0. What I like to do with these questions is I like to say u equals 2 to the power x, and so you'll see this will give you u squared minus 4u, 2 squared is 4, minus 32 equals 0. And then we'll sub 2 to the power x back in when we have our answers. So let's do this. 1 times 1, 32 times 1, 16 times 2, 8 times 4. So obviously on the left hand side, when we do our brackets, we're going to have a u and a u, and these values, when we multiply them together have to give us negative 32. So one has to be positive, one has to be negative. And then also the first u times this value has to plus the second u times that value have to sum to negative 4. So 32 and 1 probably not going to work. 16 and 2 probably not going to work. 8 and 4 probably will work, right? So let me just be to raise it a little bit too aggressive today. So what we're going to do is we've got our u here, and so we said we're going to use 8 and 4. So 8 and 4, and we want the larger number to be negative, the smaller one to be positive, so that when you say negative 8u plus 4u, you get negative 4u. Negative 8 times 4 gives you negative 32, and obviously you have u squared, and equals to 0. So we can say u is equal to negative 4, or u is equal to 8. So remember, u is just 2 to the power x. So 2 to the power x equals negative 4, or 2 to the power x. Now remember, 8 is just 2 to the power 3. So we can say this is definitely correct, x is equal to 3, but a positive number raised to an exponent is never going to give you a negative number, so this is not a valid solution. So your solution for 1.1.4 is just x equals 3. Okay, so last question. So for 1.1.5, just do this. So let's take what is under the square root, take the negative x to the other side, 2 plus x. Let's square both sides, and then we can get rid of the square root. Makes our lives a little bit easier. So negative 2x plus 4, and so this would just be 4. So 2x times 2 is 4x plus x squared. And so I think what you'll end up getting if you simplify this further is you'll just get an x squared plus 6x equals 0. So you factorize very simply, x times x plus 6 equals 0, and so you have two answers, x equals 0, x equals negative 6. Correct. So that's the first part of question 1. How are we doing for time? Okay, not too bad. So the next question, solve for x and y simultaneously. Let me just organize my notes here a little bit. So we're going to solve for x and y simultaneously. There's a couple of different ways of doing this, but we're going to try and do it in the simplest possible way. So let's make y the subject of the formula. Y equal to negative 2x plus 3 from this part of the equation. So we have y equals negative 2x plus 3. Let's substitute that into the other equation we have. So let's say, actually before we do that, let's factorize. So let's say y plus x equals 2. You don't have to do that, but I found that to be a bit easier. So then you can just say negative 2x plus 3, negative 2x plus 3 plus x equals 2. And so then what you'll get is these brackets equal to 2. And so now you know what you're going to do is just simplify that into a quadratic. So the quadratic that you get after you simplify is 2x squared minus 9x plus 7 equals 0. And so let's quickly factorize that. We have two prime numbers. And so we know that it's going to look something like 2x x. And then we need to decide which one is going to be 7 and which one is going to be 1. It's going to look like this. Right? So we want both to be negative because the middle value is negative. And we want x over here because obviously if we put 1 7, because if we put 7 over there, 2x times negative 7 is going to give you negative 14x, and that's too big. So we're just going to put it in the left hand side brackets. And so of course we say that this is all equal to 0. So you will get x equals 1 and x equals 7 over 2. And then you can just plug that back into one of these equations. So you can just take this value and plug it in over there to solve for y. Take this value, plug it in there to solve for y. So at the end of the day, I'm not going to do that just for the sake of time. I think you guys know how to plug values into equations. You're going to have x equals 1, y equals 1, and you're going to have x equals 7 over 2, y equals to negative 4 if you do the substitution. So that question is done. So the next question we're looking at is 1.3. They say consider the product 1 plus 1 over 2, 1 plus 1 over 3, 1 plus 1 over 4, and so on. And they say that each factor in the product is of the form 1 plus 1 over n for n equals 2. So what I like to do in questions like this is just make your life a little bit easier. So we know that the product is of the form 1 plus 1 over n. So we can just rewrite this as n over n. That gives you 1. So now we've got the same denominator. So this is just n plus 1 over n. Okay, so that's the general form. Okay, so the general form is given as that. So let me just move this over here. And now the question is, determine all the values of n for which the product will be an integer value. So that is a whole number. We don't want fractions. And so if you look at just the first ones over here, we can rewrite 1 plus 1 over 2 as just 3 over 2. We can rewrite 1 plus 1 over 3 as 4 over 3. We can rewrite 1 plus 1 over 4 as 5 over 4. And so I think you start to see a pattern emerging. What would the next one be? It would be 1 plus 1 over 5, and that would simply be 6 over 5, and so on. And so you can see the numerator is increasing by 1 each time, and the denominator is increasing by 1 each time. And so just to have a look how we do this, if you see a question like this and you have no idea what to do, a good idea is just to test different values. So let's try n is equal to 2. For n is equal to 2, we just have the value of 3 over 2. And 3 over 2 is not an integer. Let's try n equals 3. So that would be 3 over 2 times 4 over 3. And so the 3's will cancel, and you'll end up with 4 over 2, which will give you 2. If we try n is equal to 4, that would be 3 over 2 times 4 over 3 times 5 over 4. So you would get 10 over 4. So just the 2 over here times the 5 over 4 gives you 10 over 4. Now let's try n equals 5. If we try n is equal to 5, that would be everything we have so far. And so that would be, if you do 10 over 4 times 6 over 5, you get 60 over 20, which gives you a whole number. And so what you're starting to see develop here is that when we have even numbers, we are getting non-whole numbers or non-integers, and when we have odd numbers, we are getting integers. And so then you can simply conclude all values of n. The values of n for which the product will be an integer value is n is odd. Okay, so let's move on to question 2. I apologize for this little thing over here. I haven't figured out how to remove it from the screen, but I think all the information is still present. So they say here the first term of an arithmetic series is 7. The common difference of the series is 5, and the series contains 20 terms. So calculate the sum of the series. That's very simple. So the first term of the series is 7. So before we start, let's just make sure we are clear on the formula. So the formula for the sum of an arithmetic sequence, you will see it in the formula sheet provided as well, is n over 2 over 2a plus n minus 1 times d. Okay, so n is the number of terms, a is the first term of the series, and d is the common difference. So really they give us everything we need. So they say the sum of, what is that? We want to calculate the sum of 20 terms. So we just say 20 over 2 because there are 20 terms. We say 2 times, what is the first term? 7. We add 19, n minus 1, and we multiply that with, I believe, 5. So put all of that into your calculator. You should get a value of 1090. Okay, so let's keep that there. Now 2.1.2, the original arithmetic series is extended to 75 terms. N equals 75. The sum of these 75 terms is 14,400. So sum of 75 terms is 14,400. Using sigma notation, write down an equation for the sum of the terms added to the original series. So this is 4 marks, but it's an incredibly easy question. So how do you go about solving this? So what you're going to do is, first of all, we know that we can say the sum of the series with 75 terms minus the sum of the series with 20 terms is just 14,400 minus 1,090, and that gives you 13,310. And so now, how do we go about putting this in sigma notation? Well, we need our equation for the calculating the term, the general rule or the general term of the sequence. So the general formula for that is a plus n minus 1 times d. And in this instance, if you plug in your a value and your d value, it gives you 5n plus 2. And so when we want to do this in sigma notation, we're just going to say that n equals 1, 75 of 5n plus 2 minus the n equals 1 to 20, the same thing, same general term, is equal to 13,310. Okay, and so then finally we just say, because the question is, write down an equation for the sum of the terms added to the original series. So what we would like to do is basically just say, so we have the first 20 terms. What is the value from the 21st term to the 75th term? And that is what we have here. It gives you the same answer, 13,310. So yes, I hope that's clear. What I would advise with these questions, any question that asks you anything about an arithmetic series, just make sure that you're very, very clear. Write down your formula from the formula sheet. So make sure you understand them, make sure you have them close to you. Also make sure you understand sigma notation. So for example, over here, when I say n equals 1 to 75, it says sum up 5n plus 2 from the first term to the 75th term. And in our final answer, we're saying sum up the general term 5n plus 2 from the 21st term to the 75th term. Okay, so let's do 2.2. So this one is about quadratic patterns. So they say the sequence of the first difference of a quadratic pattern is 1, 3, 5. They say if the 99th term of this quadratic pattern is 9,632, calculate the value of the 98th term. So that's what that notation means. T99, 99th term, T98, 98th term. So we know what the sequence of the first differences is. So it's 1, 3, 5, right? And so the question is, how do we find the 98th term? So the first thing we can do is we can just use our generic formula. So the first differences pattern is just a arithmetic sequence. So we can use our generic formula for that to find out how do we find the difference for the nth term, or the first difference of the nth term. And so D in this context is the what is this? The change from 1 to 3, 3 to 5, which is just 2. So in this instance, you would have it be 1 plus n minus 1 times 2. And so the rule for the your first differences is just 2n minus 1. Okay. So now the question is, how do we solve for this? So the logic that I would use here is just to say that if we know what, for example, let's say we have this sequence. Let's say we have 0, 5, 10, let's say 20, right? So whatever this is. So this represents, let's call it D1. So that's T1 of the first differences. This represents D2. This represents D3. Okay. So if I knew, for example, what T2 was, so T2 is equal to 5, and I know that, sorry, let's do this rather. If I know that T4 is equal to 20, and I know that D3 is equal to 10, and someone asks me what is the value of the third term, I would just say 20 minus 10. So the general rule is you say if you want to find the value of the nth term of a quadratic pattern, you just say T of n. To get that, you say T of n plus 1 minus dn. So in this instance, T of 98, the 98th term of the quadratic sequence, is the 99th term of the quadratic sequence minus the 98th term of the arithmetic sequence of the first differences. So let's plug in 98 over here. So T98, we're just finding the 98th first difference. That should give you 2 times 98 minus 1. That should give you 195. And so very simply, we just say that T98 is equal to 9,632, this value over here, minus 195. And that gives you a value of 9,437. Okay, so don't get confused. It's just nice. Whenever I'm confused in an exam like this, I always use an analogy with smaller values, and then I just apply the general rule to the larger values. You can obviously, rote learn it or just know it, but I think it's useful to know. So let's erase what we don't need here. So we can keep the arithmetic sequence of the first differences, and I think we can erase the rest. So how are we for time? 30 minutes. Cool. Now, they say here, it is further given that the third term of the quadratic pattern. So let me do this just to avoid confusion. So this is the rule for the first differences, dn. Then they say the third term of the quadratic pattern is 32. And they ask us to determine the general term of the quadratic pattern. Okay, so I'm going to do a few things. So first of all, if I know what T3 is, I know what T2 is, and I know what T1 is, right? So let's do this. T1. So we know that to get from T1 to T2, we add D1. So we know that to get from T2 to T3, we add D2, okay? And conversely, to get from 32 to T2, we subtract D2, and to get from T2 to D1, we subtract D1. So we are actually given these values. So D1 equals 1, D2 equals 3, D3 equals 5. So 32 minus 3 is going to give you 29, and 29 minus 1 is going to give us 28. So at the end of this, we know that T1 is equal to 28, T2 is equal to 29, and obviously what they gave us, T3 is equal to 32. Okay. So now let's go on and ask ourselves, how do we determine the general term of the quadratic pattern? Okay. So let's do this. Let me just move this around. So what you're going to do is you're going to write out the sequence of just write out the quadratic sequence. 28, 29, 32. And so obviously we know that 28 to 29 we add 1, 29 to 32 we add 3, and 32 the next one we add 5. That gives us 37. So in this row we have the actual quadratic sequence. Okay, quadratic. Now below that we have the first difference terms. Okay, so 28 to 29, that gives you 1, 29 to 32, that gives you 3, 32 to 37, that gives you 5. And then we can look at the second difference, and that's going to be a constant 2, right? We could probably also know that, for example, this one would be 7, and that this value would be 44, but we don't need to, but you would still keep the 2 constant, right? So this is now your first differences in this row, and you have your second differences in this row. And so this is just one of those questions where you just need to know some theory. So we know that with an arithmetic sequence, it has the general form of an squared plus, bn plus c. And so how do we determine those values? So the way that you go about determining it, it's just by using a mathematical property of the quadratic sequence. So you would just say 2a is equal to 2, 3a plus b is equal to 1, and a plus b plus c is equal to 28. And so it's pretty straightforward. So let's solve for a. So 2a equals 2, so a is equal to 1. So if I say 3 times 1 plus b equals 1, b is equal to -2. And then if I do, well, let me make a little box for myself. A plus b plus c equals 28. So 1 plus -2 plus c equals 28. 8. C is going to be 29. So the general formula is just going to be, let me just confirm this, yes, n squared minus 2n plus 29. And that's your final answer. So nothing to be too scared of. Okay. So now a circle with radius 6 centimeters is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally as shown in the diagram. And then a third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. So, sorry, it's a bit hot in my room. I don't know why, so I just had to take off my jacket. So, how do we go about doing this? They ask us to write down the radius of the third circle. So what I would do is just look at this and notice that, so this is the first radius, and they tell us this is 6 centimeters. Sorry, 6 centimeters. Okay, so that means that this entire diameter is 12 centimeters. Okay, so that means that the diameter of the smaller circle is also 6 centimeters. And so we know that if the diameter of the smaller circle is 6 centimeters, its radius over here will be 3, right? And so the radius of this will be 3. And so if we look at this smaller circle, what will its diameter be? Well, we need to get to 12. So 6 plus 3 plus 3 get us to 12, and so half of 3 is 1.5. So the radius of the third circle is 1.5 centimeter, and you can see that we're just halving this. So the first radius is 6 centimeters, second is 3, third is 1.5. Okay, now we calculate the sum of the areas of the first 10 circles. So just note, what do we have here? We have a geometric sequence. So what is the general formula for the sum of terms in a geometric sequence? This is the formula. Where A is your first term and R is your ratio. So they want the sum of the first 10 circles. So what do we have? So we know what n is. So we know that we're going to say S of 10 equals, do we know what R is? Well, we'll get to that in a bit. But it's pretty simple for us to figure out what A is. So the first circle, so what is the formula for the area of a circle? It is just pi r squared. And the first circle has a radius of 6. So A is equal to 36 pi centimeters squared. So that's the area. So that's nice to have. So we have that component of the formula. And now the question is, what is the value of R? Now, don't just say that R is equal to half because the radius is reducing by a half each time. Remember, we are summing the areas. So we want to compare how the area changes over time. So let's look at the second term. So a radius of 3 centimeters. So pi 3 squared equals 9 pi. And so you'll notice from the first area of the first circle to the second, we are multiplying by 1 over 4. And you can verify that with a second circle, we will multiply by 1 over 4 again. So what we have here for R is 1 over 4. You can also swap these around, probably actually better to say 1 minus R in this instance. But if you plug in those values to the formula, I believe the answer you will get is 150.5. 0.8 centimeters squared. Okay, in the memo it doesn't seem they're pedantic about explicitly saying centimeters squared, but where I did my high school education, they like to punish you for not adding that. And now they ask us, given this information, they ask us which circle has a diameter of 3/128. So first of all, let's make sure we have our formula for the nth term of a geometric sequence. That's the formula. Okay, a, r, and then r is to the power n minus 1. And so what they're saying is, the question is asking us what's the value of n, right? Which circle? So is it the first circle, the second, the 10th, the 100th? So what are we going to do? So we already have a, which is nice. So a we know is 36 pi. And we have r, which is just a quarter. And this is n minus 1. And so the question is just, it's a bit late in the evening. That's why you should read your questions carefully, learn from me. So which circle, not area, has a diameter, diameter, you guys were probably screaming that at me as I was doing that, has a diameter of 3/128 centimeters. So here we want to figure out what the geometric sequence is. So we know that for what we did previously here, let's do the diameter. So the diameter of the first circle is just twice its radius, which is 12. Then for the second it's 6, and then for the third it's 3. So you'll notice each time we are halving it. So our r over here is a half when it comes to the geometric sequence for the diameter. Okay, so there's a difference between the geometric sequence for the radius, for the diameter, and for the area. So don't make that mistake. So r is equal to a half, and a in this instance, it's not 36 pi, that's area, it is 12. Okay, and so what are we going to have on the left hand side? We're going to have 12 times a half to the power n minus 1. And what we want to know is, solve for n if I equate this to 3/128. Okay, so how I've done this is I would say divide both sides by 12. So you would have 1/2 here, n minus 1. And so just, I guess, multiply both sides by 1/12. The right-hand side simplifies to 1/512. And if you're smart, or even if you're not, you will notice that 512 is 2 to the power 9. And you can just test, you can play around with your calculator and find out what, what 2 is, 2 to the power what gives you 512. But you can rewrite this. So remember, because we have 1/2 equal to 1/512, we can just swap the numerator and the denominator, because a half to the power 2 gives you 1/4, and 2 to the power 2 gives you 4. So if we're comparing denominators to denominators, numerators to numerators, it doesn't matter. So we can simply say 2 to the power n minus 1 equals 2 to the power 9, and that means that n is equal to 10. And then what you could also do, if you did not notice that, is you could use logs. So you could simply say n minus 1 log over half equals to log of 1/512. And so you would say n minus 1 equals to log 1/512 divided by log over half, and you can take this and say plus 1 over here, and you would get the same value, n equals 10. Okay, So which circle has a diameter of 3 over 128 centimeters? It is the 10th circle. And you can verify this by plugging it into the formula, but we're not going to do that. I'm too tired. I'm sorry. You guys can do that at home. You guys have more free time than me. So now let's move on to this question. So they tell us that we have f of x equals to a to the power x minus 1 for a is greater than 0. And they give us a point on f. So they ask us, please calculate the value of a. Very simple. We are just going to plug in the point. So f of x is the same as y. So we plug in this coordinate for y, negative 5 over 9, equals to a squared minus 1. And so then we can say 9 over 9. So we take this negative 1, add it to the other side. So 1 is the same as 9 over 9, equal to a squared. I don't know why my thing is glitching over here. Okay, and that will give you is 4 over 9 square rooted is equal to a, and so we can say a is equal to 2 over 3. Please don't get confused between my a's and my 9's. I know they can sometimes look a bit similar, but they are different things. Just depends on how enthusiastically I'm writing, to be honest with you. So now they want us to write down the range of f, okay? And so let's just think about this question very logically. So now what do we have? F of x is equal to 2 over 3 to the power x minus 1, right? And obviously a is greater than 0. That's why in the previous question when we did the square rooting, technically it's a plus minus, right? But a is greater than 0, so we choose the positive answer of 2 over 3. So what is the range of f, right? So what values can f take on, and what values can it not, or what values will it always be greater than, always be lesser than, that sort of thing. So what I would do in this question is let's take x and make it super big. So let's make this positive infinity. So I hope you guys know that any fraction to the power infinity essentially approaches 0. Okay. So if we take the largest possible x value we could think of for f of x, we still wouldn't be able to make it, less than negative 1, right? And also it would decrease, and then basically approach negative 1 but never touch negative 1. And then if we say let x approach negative infinity, then what we will have is just 3 over 2 to the power x, my word, right? Because 2 over 3 to the power negative x is the same thing as 3 over 2 to the power x. So if we're saying, 2 over 3 to the power negative infinity, it's the same as saying 3 over 2 to the power positive infinity. And that will just give you infinity minus 1, which is infinity. So as we go to the left, the range of f becomes super, super big. But as we go super far to the right, in terms of the x-axis, it can never be less than negative 1. So what is the range of f? Y greater than negative 1. Not greater than or equal to, because it never actually touches negative 1, no matter how far we go to the right. Okay, and so I think that question should give you a good idea of this next one, where they say sketch the graph of f, and clearly show the intercepts with the axes and asymptotes. Okay, so the first thing we can do is just one basic intercept that we can always ask ourselves is, for which values is this equal to 0? So if we say 2 over 3 to the power x equal to 1, the value, the answer we get for that is x equals 0. And so when x is equal to 0, y is equal to 0. Because 2 over 3 to the power 0, anything inside a bracket to the power 0 is 1. And so 1 minus 1 is equal to 0 and satisfies the equation. So our intercept, or the one intercept we have, is definitely going to be x equals 0, y equals 0. And so let's draw the graph. So I'm going to draw it very roughly over here. So here's our asymptote. Let's call this is -1. And so what's essentially going to happen is the graph is going to look, at least over here for this part, it's going to look something like this. So it's going to come close to the asymptote and never touch it. And then on the left hand side, it'll be increasing. So you can draw that a bit neater when you do the exam, but that's the general shape and you will get a mark for that. And then let's do the next question. It is further given that C is a point on F at y equals 18. Okay, determine the coordinates of C prime, the image of C when C is reflected about the line y equals x. So now something that you should know is that if I have if I have some graph, right, especially think of this. If I have a graph that looks like this, right, and I reflect it over the y-axis like so, okay, let's say over here, look at this point, okay, so let's call this point A. So let's say it had a value of -1, 10. So the x value is in the negative quadrant, 10 is positive. Now if you reflect that over the y-axis, okay, this will be A prime. And so what you'll see here is that our x value is now positive and it's quite far to the right, it's 10. And our y value is slightly negative, it's -1. So when you reflect something over the y-axis, all you need to do is take the original coordinates and just swap them around. So x becomes y, y becomes x. Okay, so knowing that, having the intuition behind it, that's how we're doing for time. Okay, the hour's almost done, but we'll keep pushing. Maybe I'll do question 5 as well. They ask you, determine the coordinates of C prime. Okay, so how are we going to go about doing this? So we know that C is a point on F. So to find the x coordinate, we can just plug in y. So we can just say 19 over 8 equals 2 over 3 x minus 1, right? And so then that tells us we have 27 over 8 equals 2 over 3 to the power x. And again, you can solve this with logs, or what you could do is you could just rewrite this. So you could just rewrite the left hand side as 3 over 2 cubed, because 8 is the cube root of 8 is the cube of 2 and 27 is a cube of 3, and then you can just swap these ones around and then have that be negative. Oh my word. And so then we can say that 3 equals -x. X is equal to -3. So we know our original coordinate is -3, 19 over 8 for C. So for C prime, we just swap them around. It's going to be 19 over 8 and -3. So yeah, there you go. Not too crazy. Oh, this question. Oh my word. It's not a very difficult question. Just not the sort of question you necessarily want to be thinking about at 4 in the morning, if you get what I mean. So let's start. Write down the value of P. Okay, so we are given this graph, f of x equals a over x plus p plus q, and we're given the domain. So essentially the domain is just telling us there's an asymptote at x is equal to 1. So it can really include all values, just not including 1. And they tell us the graph of f cuts the x-axis at 0, 1, and that a line of symmetry is given by that g of x equals x minus 3. Okay, great stuff. So how do we get the value of p? Well, when you have something like this, whatever it is, a over x plus p, the reason why the equation works the way it does is because you cannot divide by 0. Okay, so if you want to find the value of p, you can just say for which values of p is x plus p equal to 0, right? Well, we already know that when x is equal to 1, the denominator is equal to 0 because that's our asymptote. So we know that if we plug in 1 plus p into the denominator, we will get 0. And that is why we have that asymptote, and that is why that value is not a a valid value that you can plug into f of x, because it gives you an impossible answer. And so the value of p here is just -1. Okay, that's nice to have. Then determine the equation of the horizontal asymptote of f. So that is this over here. So they basically want this, they're saying y is equal to what for that horizontal asymptote. So what do we know here? Well, we know there's this horizontal asymptote. We also know we have this line of symmetry. So we have this intersection point where the line of symmetry, the vertical asymptote, and the horizontal asymptote meet, right? So if we know what the y coordinate of that point is, it also tells us the equation of the horizontal asymptote, because the horizontal asymptote will just be, y equals something, and that y coordinate will just be the same for all values of x across the asymptote. So all we need to do is solve for the y value of that point. And it's pretty simple, because we know that the equation of this line of symmetry g is equal to x minus 3. And we know that the value at the intersection point is where x is equal to 1. So it's just -2. So the equation is, or the coordinate is 1, -2. And so then the answer here is just that y is equal to -2. Okay, let me just make that a little bit neater. I hope that what I lack in neatness of handwriting, I make up for in clarity of explanation. The 5.3, the question is calculate the value of a. Okay, so a few things that we know. So let's write what we have. So f of x is equal to a over x minus p, which is or x plus b, which is -1, plus q. Now I just want to note here, the value of q in a graph like this is always equal to the horizontal asymptote. That is just a property of graphs that look like this, right? So usually when you have your standard line or parabola, it'll be the value, it'll just be a y-intercept. But in something like this, in a graph looking like this, the name escapes me, just know that the value of q will be your horizontal asymptote. So that's why q is equal to -2. And so they ask you to calculate the value of a. And so all we need to do for this is just take a given coordinate. So for example, here the given coordinate is 0 and 1. And we just plug it into the formula and solve for a. So let's do it. So if I say f of 0 equals 1, that means a over -1 minus 2 is equal to 1, sorry, I know that a over -1 is equal to 3, and I know that a is equal to -3. I just multiplied both sides with -1. So a is equal to -3. And so now we have the full, I guess, equation of what we're working with here. For which values of x is f of x greater than 0? So this is, really simple to do. We just take what we plug in our values that we've got for the equation of f of x, which would be a is -3 over x minus 1, because p is -1. And by knowing our properties, we know that q is -2. And we just ask ourselves, let's find out for which values of this, what values of x give us an answer of 0. And so I'm not going to do the very basic algebra and the simplification. I think you might also agree with me that might be a slight waste of time. But you will get x is equal to a -12. Okay, and so now they ask you for which values of x is f of x greater than 0, right? And so the answer for that is that x has to be greater than, remember, the question is greater than or equal to 0, so we can use including signs here. So x is greater than or equal to -12, but less than 1, right? And so why? So remember, this is our asymptote, okay? So we get close to 1, but we never fully reach it, right, for this value of f. And I think you'll note here that for this curve of f, this part of f, all of it is negative, right? The x's are negative, the y's are negative. It's just a very depressing part of the graph. But for this graph, we know that this section, starting from x equals to -12, is positive. And so if the question is for which values of x is f of x greater than 0, it is these values, right? I hope that makes sense. And then they tell you graph f undergoes a transformation to h where the domain and range of h are the same as that of f, and that h prime x, the derivative of h, is negative on its domain. Describe a possible transformation that f could have undergone to result in h. So the simplest way of doing this is, first of all, what does it mean for h prime of x, the derivative of h, to be negative on its domain? So have a look here. So you'll note here that for this graph, if we draw a tangent, it's upward sloping for all these values. And the same for this one. If we draw a tangent, they're just always positive. So now they're saying, can you reflect this or change it or transform it such that it becomes negative, right, for all values of x you could possibly plug into it? And so what I see immediately looking at this is I just go, well, what about this, right? Because if we look here, every single tangent you could ever draw on the entirety of the domain is negative, and it's going to have the same domain, right? And it's going to be negative sloping. And so your answer for h is just going to be, let me just get the exact wording for you guys. We're going to reflect f about the line x equals 1, right? Because this is the line that we're reflecting it about, line x equals 1. So we're just reflecting it like that, okay? And so that satisfies the question. So we have the value of p, -1, horizontal asymptote is -2, value of a is -3. We were able to solve for q using theory. We know that q is just the value of the horizontal asymptote. We know that f of x is greater than 0 for x between -½ and less than 1, not including 1. And we have told them what a possible transformation could be. A reflection of f about the line x equals 1. Okay, now I need to decide how much I love educating people for free. It's 4:09 a.m. Let's do question 6, sure, why not? And then I'm gonna go to bed. So by the end of this question, you should be at the end of part 1. I mean, I guess it's cool, right? Because we did the first half, 6 questions of the exam, and I'll do the other 6 questions tomorrow. Yeah, and I think this is pretty standard timing for a walkthrough video. It's about an hour each part, so it'll be 2.5 hours in its entirety. I have tried to go a little bit slower than I could have. So let me know in the comments what the pace felt like. Did it feel too fast? Did it feel too slow? Just so I can adjust for the future videos that I make. And also let me know if this video helps at all, or if it just made you more confused. So question 6, in the diagram below, the graphs of f of x equals -x squared plus 4x plus 5 and g, a straight line, are drawn. C, which has coordinates x equals 3, y equals 8, is a point of intersection of f and g. EH is drawn parallel to the y-axis with E a point on f and H a point on g. So calculate the coordinates of B, the turning point of F. So I love these questions. They're like super easy. So we know what f of x is. -x squared plus 4x plus 5. Nice, beautiful. How do we do turning points? We find the derivative and we equate it to 0. Why do we do that? Because if you draw a tangent over here, the derivative is equal to 0 because the tangent is equal to 0. It is neither increasing nor decreasing at point B. So great stuff. So let's do the derivative of fx. So -2x plus 4. So -2x equals -4. X is equal to 2. So I hope you guys know how to do derivatives. So you just take the exponent, multiply it in front, and then subtract it by 1. And then same with x to the power 1. Put 1 in front. 1 minus 1 is 0. You're left with 1. So the value of x is 2. Also, sorry, I live in an observatory and I don't have a very nice noise cancelling mic. So people are having a very fun time outside. We'll just wait for them to pass while we focus on mathematics. And so now we have that coordinate, which is x is equal to 2. And all you have to do is just plug that into the formula for f of x. So I'm not going to do that tedious work. You'll get 9. Okay, so there we go. Coordinates, 3 points, easy marks. Then they say, show that the equation of the line through A and C, let me just erase this, through A and C is given by g of x equals 2x plus 2. So, whenever we want an equation of a line, we just need 2 coordinates and then we've got it, right? So we've already had half our job done by the examiner. They give us 3 and 8. Now we just need to know the value of A. Okay, so what do you know about A? A is where g is equal to 0, but more importantly, it's where f is equal to 0. So if we just say -x squared plus 4x plus 5 equals 0, we will solve for these 2 values, A and D, and then we'll just choose the -1. So I like to, with these questions, just multiply out by negative, makes the calculations slightly easier for myself. So multiply the left and the right hand side by -1, 1, 1, 5, 1, x, x1, and so we'll have the bigger number be positive or negative and the smaller number be positive because the x value has to be negative. So we get x equals -1 x equals 5. So we know that this has a coordinate of 5, 0, and then this has a coordinate of -1, 0. Great. And then I will do this calculation, but you should, if you've passed grade 9, you should know how to do it. How do we find the equation of a line through 2 points? So firstly, what is the gradient? It is just given by this formula. And so we can just say 8 minus 0 over, I don't know why this thing is being so funny. So we can just say, please work. We can just say 8 minus 0 over 3 minus -1, which gives us 8 over 4, which gives us 2. So immediately we know that y is equal to 2x plus c. And then you can just solve for c, just substitute, for example, these values or these values into the equation, and you will have shown the examiner that that is the equation. Okay, great. Now they say calculate the maximum length of E of h for f greater than g. So what are the values of f greater than g? It's these values. Does this highlighter work? No. It seems to be useless. Wait, it's not useless. There we go. So like many people have told me, well, you guys your age will say that I have unk status, but I am still quite hip and with it when it comes to the technology. Don't worry. So that what I've shaded in green is everything where f is greater than g. And so they say, what is the maximum length of E of h for f greater than g? So what you could really notice here is that what is E of h? Or what is EH? EH is just f minus g. So f minus g is the same as saying -x squared plus 4x plus 5, right, minus 2x plus 2. That gives you E of h. So the formula for E of h, let's just have a look here. The formula for E of h is, once you simplify it, going to be -x squared plus 2x plus 3. And if we take the derivative, it's going to be -2x plus 2. Now we want the maximum length, so we want a turning point. And so we're just going to say, well, let's find the x value that gives us, because the y value of E of h, the output of E of h, is the length between f and g. So we want to find the x value that gives us that output. So let's find a turning point. So -2x plus 2 equals 0. -2x equals -2. X equal 1. So let's substitute that back into this formula. And what you'll get is 4. So the answer here is 4, positive 4. And then, what a monster. Given k of x equals f of x plus m equals -x squared minus 2mx minus m squared plus 4x plus 4m plus 5. Whole nice long equation waiting for us. Determine the value of m such that g is tangent to k. So we will do that. I will also give you guys a tip to not practice your math at 4 or 3 or 2 or even 1 in the morning, because it is definitely not the time when your brain is the most alert. But nevertheless, sometimes it is necessary, especially if you guys are crammers like I am. Don't be crammers, by the way, but a lot of you are anyways, and nothing I say is going to change that. So maybe it's good sometimes to know how to cram. Just don't make it too much of a habit. How are we going to solve this question, right? So let's do this. Let's call f of x plus m. Let's call it something else. Oh, they've already called it something else for us. They've called it k of x. Okay, so it's already there. I'm not going to rewrite it. But let's do this. Let's just group like terms. So negative x squared, cool. So we know that we have these two terms have x's in them. So let's say negative 2mx plus 4x. So we've done that one and that one. And then let's say negative m squared plus 4m plus 5. Okay. Now they say determine the value of m such that g is tangent to k. Okay, before we get there, let's just reorganize this a bit more. But what we're basically going to say, or what we're going to end up doing, is we're going to say, have k of x equal to g of x. Okay, that is going to give us a quadratic. And then once we have that quadratic, we're just going to check the determinant. And we're going to check which values of m ensure that b squared more than minus 4ac is equal to 0. Okay, that's what we're going to do. So if I say k of x, sorry, I'm going to abandon this thing of making k of x more neat. K of x equals g of x, right? You guys know what all those things are. I'm not going to go through the tedious process of simplifying it. But if you go and do that tedious process, or just trust me, you will simplify it to something that looks like this. And so now we have it in the form of a quadratic, where a is equal to 1, b is equal to 2m minus 2, c is equal to m squared minus 4m minus 3. Okay. Wonderful, wonderful, wonderful. Great stuff. Now, all we need to do is just say b squared minus 4ac equal to 0. Really quickly, why does that make sense? So I'm just going to quickly show you guys this with the parabola, right? So a parabola that looks like this, right? I'm just going to call it the determinant. I'm just going to call it the triangle. Your triangle is going to be less than 0. So it has no real solutions, no real solutions for x. A parabola that looks like this, right, is going to have a determinant that is equal to 0. So it's going to have one solution. And then a parabola that looks like this is going to have a determinant greater than 0. That's because when you use the quadratic equation, you get it to a point where you have this thing that says plus minus square root of b squared minus 4ac. And so if the inside the square root is a 0, you just get one answer. If the inside of the square root is positive, you have two different answers, a value plusing that answer and a value where you minus that answer. And obviously if it's less than 0, you can't take the square root of a negative number, and so you have no solutions, no real solutions. So just to give you guys the intuition behind that, I don't know if you feel like I'm wasting your time by telling you that because you already know it. But in my experience, I'm always shocked by how little people know, never by how much they know. Well, I've been shocked by how much people know, but much more often how little people know. So let's just plug this into a little formula. That's our b squared minus 4a, and c is m squared minus 4m minus 3. Okay. And so I'm just going to erase this to give us some space. Okay. And we solve for equal to 0. So, guys, the amount of simplifying that you do is really a loss here. Eh? But just trust me on this, okay? That once you simplify it, low key, you're going to get 8m plus 16, okay? Low key. And that is without, doing a quadratic solution, because you're going to have, just notice here, this is going to give you negative 4m squared, and this is going to give you 4m squared. So they will cancel out, so it's nice. You don't have to solve for a quadratic, right? And then that'll be equal to 0, and then that gives you m equals -2. Whew, there we go. Determine the value of m such that g is tangent to k, m is equal to -2. Okay, so we've proven that. We've got those coordinates, we've got the maximum length, we've solved that. So we've gotten full marks. Well, I have. You guys haven't even written your exam yet. You might get 0. God forbid. Okay, so that is the end after 1 hour 23 minutes of part 1. Not bad. The second half of I think this was definitely the harder section. The last questions are quite a bit easier. So just to give you guys a preview, what I'll upload tomorrow, but you're probably not watching this you're probably watching this a week or 2 from now, or you're like cramming the night before the exam, so this doesn't matter. But we'll do question 7, which is on, money, time value, depreciation. We'll do question 8, some basic derivatives, equations of tangents. We'll do question 9, derivatives from first principle, that sort of thing, domains, inverses. We'll do a little bit of, some concavity, some intercepting, some shifting around cubic polynomials. And then we'll do this thing, a little bit of speed, and you guys don't get taught integration for some reason. I don't know why the CAP syllabus doesn't do integration, but yeah, this thing where you do speed and distance and time and all that. And then we'll do a little bit of basic probability, and then we'll do a little bit of permutations and combinations. I don't know what they call that in your textbook, but that's what it's called. Great stuff. So if you guys enjoyed this video, and if you have stayed this long into the video, you must be a committed student. Please like the video. Please comment. So maybe rate the video out of 10. 1 being that I should delete my YouTube channel and never ever teach anyone anything again. And a 9 being that I changed your life and I changed your outlook on mathematics and the concept of life itself after this video. And so please subscribe, please share this video with anyone that you find it to be useful, and stay tuned for more videos. If you enjoy my style of teaching, and if you would like a little bit of extra help before your math exams, I am quite time constrained, but I do have some time, some few hours in the week available for math tutoring, although quite limited. And so what I will do is I will leave my email address in the description, and you can email me, and you can just tell me which grade you are, preferably obviously grade 12 if you're watching this. You can tell me what exactly you're struggling with, and then we can go about arranging sessions. But I will continue uploading exam walkthrough papers and anything I find useful. So yeah, until next time.